Hello and welcome to another video. This time we're going to be looking at the SSD1306 OLED displays. These little displays are only about an inch across, but they pack in 128 by 64 pixels and they're available in a few different colours. On the back of the module you can see the i2c pins, and some of them have an ID adjust but not all of them. They don't also follow the same order for the i2c pins, so watch out as some of them may be a different way round. Looking at the display of 128 by 64 pixels, it's important for us to understand how the memory is organised so we can put our own graphics onto the display. So this is how the memory is allocated. There are 8 different rows, sometimes referred to as pages, and then there are 128 columns across. Each of the columns across is 1 pixel, but each of the pages stores 8 different pixels, so all of the 8 pages combined vertically will create the 64 pixels. If we look at one individual byte, we can see that the pixels are arranged vertically, with the least significant at the top and the most significant at the bottom. So if we wanted this arrangement of pixels, we could work out what the actual value of that byte should be. If we want to put some text or graphics onto the display, we simply put one byte after another to make up the display we want to see. In this example here, and the code we're going to look at, we've created a font which is 6 pixels wide and 8 pixels high. I've included a simple spreadsheet so you can edit and create your own characters. Make the changes you want in the top block, and down below the actual line of code you'll need is created. If we take a quick look at the display, we can see what our code is going to do. We print some text on the screen and some custom characters. We've also got an animated Pac-Man running across the bottom of the screen. So if we take a quick look through the code that we've got today, there are a few constants defined at the top. I've also listed the main routines that I've provided within this file, which you can then use in your own projects. The oLed init display sets up the display ready for communication. oLed clear display is pretty obvious, it clears the screen. Set oLed cursor position takes B and C as the column and the row to set the current position. There's a routine for printing a single character and a routine for printing a string of characters based on the font that we've defined within this file. There's also a command for inverting the whole display or setting it back to a normal state. And if you want to send your own commands or data, then there are some routines defined for those as well. So at the beginning we clear the screen on our Agon and put some text so we know what's going on. We then open the i2c bus. We then call the oLed init display routine. We wait for a moment to let it settle down, and then we clear the display. The next thing we're going to do is print some of those characters that we saw on the display. So for each one we specify the location and then set the cursor to that point. And then we say what we're actually going to print and send the command to do it. So in this case a string is going to be printed at the location 12 across and 2 lines down. We do the same for a second string. We then set the cursor to 0, 0, and we set one of our user-defined characters, which is a little box. Next we print the same thing in the top right hand corner, and then print a couple of little men characters, again on the top row. Now most of the code here is going around in a loop waiting for someone to press the escape key. So this is the same code that we've seen before. We're also setting up B as a counter as we're going to animate a character across the screen. In addition, we check if someone presses the I key to invert the display or the N key to put it back to normal. And the routine is fairly straightforward to animate our character across the screen. The first thing we do is clear the previous position with a space character. We increase the position across the screen. We set the new position and then we decide which character we're going to print, because we're only changing it every 4 frames, otherwise it will flicker too much. We then print that character. We have a short delay, and then if we haven't reached the other side of the screen yet, we carry on round. If we have, we delete that end character and reset the counter and start again. All of the oLed functions are found further down in the file. I won't go through them all in detail, but they're fairly well documented, so you can have a look at your own pace. Maybe you could use an oLed display in your project.